All right, so remember, we have 4 terms, so that means factor by grouping. So we need to go ahead and group these. But before we can do that, we need to rewrite these in the correct order. They need to be in descending order. So it's 5p cubed plus 10p squared minus 7p minus 14. So we need to make sure we put these in the correct order. Then we're going to go ahead and group the first two together. 5p cubed plus 10p squared. It's always plus in between, and this sign always follows that number. So it's minus 7p minus 14. Common terms that we have out of here are both a 5 and a p squared. So we factor out 5p squared. So we're left with p plus 2. And if you're not sure, just divide each one by 5p squared and see what you're left over with. All right, now we need this to be a positive p. So I know right away I'm going to factor out a negative. And 7 goes into both 7 and 14. So I need to factor out a negative 7. And that way I'm left with p plus 2. All right, now after that, since these two are exactly the same, I can rewrite this. This was 5p squared as 5p squared minus 7, and then times p plus 2. All right, that's it for that problem. All right, so now for here, 4 terms, factor by grouping. So I'm going to go ahead. There's no GCF. We don't have to rearrange. So I'm going to go ahead and group 16a cubed minus 6a squared. We always add, and this sign always follows that number. So minus 8, this should have been a, plus 3. All right, then we look to see what are common terms that we have. Well, here we can factor out a 2 and an a squared. So when we factor out 2a squared, we're left with 8a minus 3 minus 3. All right, now if you notice, this is exactly what we have here, but different signs. It's 8a, negative 8a, minus 3, positive 3. So that means we need to factor out a negative 1 out of here to change its signs, because when we factor a negative 1 out, it changes all of our signs. So now we have the exact same binomial. So this can then be rewritten. This is a square. I'm sorry, I keep forgetting to write that square. I'm saying it. I just keep forgetting it. It will be 2a squared minus 1 times 8a minus 3. And that is your final answer. All right, so for this problem, we rearrange first, and then we look for GCF. Well, all of these are divisible by 8, so we're going to take out the GCF first, and we're left with m cubed plus 4m squared minus m minus 4. All right, then we go ahead and we're going to group these. Now, I'm going to highlight this because I'm not going to write this every single step out. I'm just going to circle it, highlight it, and remind myself it's there to put it at the very end. So we're going to group the first two together, m cubed plus 4m squared. It's always a plus in between. This sign follows that number, so it's minus m minus 4. Our GCF from here is m squared, so we factor out the m squared. We're left with m plus 4. So we need a positive m and a positive 4, so that means we need to factor out negative 1 out of here. Now we can go ahead and group these two together. So it's m squared minus 1 times m plus 4. Now you might think that you're done here, and don't forget about the 8 out front. You might think that you're done here. However, we have 2 binomials, and this is a subtraction. We need to see, can I take the square root of each? Well, the square root of m squared is m. The square root of 1 is 1. So this can factor out even more because it is a difference of 2 squares. So it's m minus 1 and m plus 1, and then we still have our factor m plus 4. All right, so that's our final answer for that one. So you must factor completely. All right, once we see that we have 2 terms, there's only going to be one method that we look for. Step 1. Is there a subtraction sign? It could be in front of this number or it can be in front of this number. It doesn't matter where it's written. One of them just has to be subtracted. And if we have that, check. Then we move on and say, can I take the square root of each of these numbers? Well, the square root of 4x squared is 2x. The square root of 1 is 1. So since we have a subtraction and we can take the square roots of both, we can write 2 binomials. And then we write our square roots in 2x and 1 and 2x and 1, and one of them gets added and one of them gets subtracted. And that's your final answer. It's a difference of 2 squares. All right, first thing that we do here, again, we see we have 2 terms, so I know we're going to do difference of 2 squares if it works. However, we need to take a GCF out first. We can't forget that. So here we see that we have 116. Well, 4 goes into both of those. And when I take out the 4, I'm left with 25n squared minus 4. So you must take out your GCF first. Then we look and see, do we have a subtraction sign? Check. Can I take the square root of each? Well, the square root of 25n squared is 5n. The square root of 4 is 2. So check, we can do that. So now we write our 2 binomials. We write the 2 square roots, 5n and 2, 5n and 2, and then we just write plus and minus in front of the number, the square root that had the minus sign. So if this was minus 25n squared plus 4, then the 5n will be positive and negative. Right? Remember, step one for any problem is rearrange and look for GCF. All of these are divisible by 4, so if I factor out the 4, I'm left with n squared plus 8n plus, let's see, 124, so 16. Right? Remember, our very first thing that we look for when we have a trinomial, it's the first method because it's quickest, easiest, and if it works, it saves you time. You can still use the x method for this, but since both of these are positive, and I can take the square root of n squared, and I can take the square root of 16, I'm going to check and see, is this a perfect trinomial square? Well, n times 4 gives me 4n. I double it. That's 8n. It matches our middle term. So yes, this is a perfect trinomial square. So we can write the 4 that we factored out first. Then we write a binomial squared. We write in our 2 square roots. So our n and our 4. And whatever sign we have here is the sign in front of our middle term is the sign that we use. So this is our final answer. The x method will still work. This might take a little bit longer and a little bit more thinking. All right, so remember, the very first thing that we do, no matter what problem we have, is we rearrange in GCF. So although you might say, well, wait a minute, I can take the square roots of these, you can't do that first. You must take out your GCF first. And there is a GCF of 4. And if we factor out a 4, we would have then 25m squared minus 30m plus 6. I'm sorry, that's not plus 6. I don't know what I was thinking, but plus 9. Right, plus 9. All right, now we have 2 positive signs. So check, we can start maybe using our perfect trinomial square. I can take the square root of 9, that's 3. I can take the square root of 25m squared, that's 5m. So now we multiply them, that gives me 15m. Then we double it, and that gives me 30m. Remember, we disregard the sign when we're doing the steps. We're just looking for the numbers. So since it works, I know I can write my GCF and then my binomial squared, and then the 2 square roots, 5m and 3, get written inside, and this minus sign, and the sign in front of our middle term gets written out front. So our final answer is 5m minus 3 squared times 4. All right, that is it for this video as well. I decided to do this right before school started, so class is about to begin, so I'm going to finish these today. But all these will be posted for you.